The Pacific doesn't whisper along the Malibu cliffs. It crashes, it erodes, it tests everything built against it. And yet, suspended above that chaos, there's a structure that doesn't just survive the ocean, it dominates it. Tony Stark didn't build a mansion. He engineered a statement. Perched on the edge of a brutal, unforgiving coastline, the $300 million Malibu mansion isn't just a home. It's a fusion of aerospace-grade engineering, experimental architecture, and a mindset that refuses limitation. Every line, every material choice, every system inside the structure answers one question. How far can you push reality before it breaks? Because this isn't fantasy. Strip away the holograms, the suits, the cinematic polish, and what you're left with is something even more impressive. A house that could actually exist. Let's start with the most dangerous part of the entire build, the location. Malibu cliffs are notoriously unstable. Coastal erosion, seismic activity, salt corrosion. This is one of the worst possible places to anchor a luxury structure. Traditional mansions retreat from the edge. They play it safe. This one leans forward. To make that possible, the foundation wouldn't rely on standard concrete footings. We're talking about deep caisson systems, massive cylindrical shafts drilled directly into bedrock, reinforced with high-tensile steel cages, then filled with marine-grade concrete designed to resist decades of saltwater exposure. But that's only the beginning. The real innovation lies in the cantilever design, the sections of the house that extend outward, hanging over open air. Structurally, this demands a balance of forces so precise that even a slight miscalculation could compromise the entire frame. To achieve this, the mansion would require a hybrid steel superstructure, similar to what you'd find in modern suspension bridges. Load distribution isn't vertical. It's dynamic, spreading across a network of beams that redirect stress back into the anchored core of the building. In simple terms, the house holds itself up by constantly redistributing its own weight. Now add earthquakes into the equation. California isn't stable ground. Any real-world version of Stark's mansion would need advanced seismic isolation. Think base isolators, shock absorbers, and flexible joints that allow the structure to move independently from the earth beneath it. Instead of resisting earthquakes, the house adapts to them. That's the difference between surviving and engineering dominance. And then there's the material science. You're not building this with standard luxury finishes. Glass walls facing Pacific, they'd need to be multi-layered, laminated, impact-resistant panels, capable of withstanding hurricane-force winds and debris impact while maintaining perfect transparency. Steel components, likely coated with corrosion-resistant alloys, or even titanium blends in critical stress points. Not because it's flashy, but because failure isn't an option at this level. Even the concrete mix would be customized. High-density, low-permeability formulas designed to block salt intrusion and prevent long-term structural decay. Every inch of this mansion is built like it expects to be challenged, because it will be. Now step back for a second. What you're looking at isn't just a luxury home. It's a private research-grade structure disguised as architecture. The kind of place where engineering boundaries are tested daily, not just admired. And that's before we even step inside. Because once you enter Stark's world, the house stops being a structure and starts becoming a system. Step inside, and the illusion of a home disappears almost instantly. There are no switches, no visible controls, no friction between intention and action. Because this house doesn't wait for commands. It anticipates them. At the core of Tony Stark's Malibu mansion is an artificial intelligence system inspired by JARVIS. But in a real-world scenario, this wouldn't be a single voice assistant sitting in a server rack. It would be an entire distributed intelligence network embedded into the structure itself. Every wall, every floor panel, every ceiling surface becomes part of a sensory grid. LiDAR mapping continuously scans spatial positioning. Microphones isolate voice patterns even in open environments. Thermal sensors track body heat and movement. Cameras, hidden, seamless, build a real-time behavioral model of the occupant. This isn't surveillance. It's synchronization. Walk into the living space, and the system already knows your posture, your pace, even your stress levels. Lighting adjusts not just brightness, but temperature, angle, and diffusion, calibrated to your biological rhythm. Music doesn't start randomly. It flows and based on pattern recognition, habit learning, and contextual awareness. The house isn't reacting, it's predicting. And to make that possible, the computing power behind it would rival small data centers. We're talking about localized edge computing nodes distributed throughout the mansion, minimizing latency to near zero. Instead of sending commands to the cloud and waiting for a response, the house processes data internally, instantaneously. Because in Stark's world, delay equals inefficiency. Now take that intelligence and connect it to the physical structure. Glass walls? Electrochromic panels capable of shifting from transparent to opaque in milliseconds. Not just for privacy, but for thermal control, reducing solar gain during peak hours, optimizing interior temperature without over-relying on HVAC systems. Floors? Embedded with pressure-sensitive materials that track movement patterns, allowing the system to map behavioral routines over time. Even the air isn't passive. Advanced filtration systems analyze air composition in real time, adjusting oxygen levels, humidity, and particulate filtration to maintain peak human performance. This isn't comfort, it's optimization. And then there's the energy system, the silent backbone of the entire operation. A house like this doesn't depend on a single power source. It operates on a hybrid microgrid. Solar arrays integrated into the architecture capture energy throughout the day. Battery systems, far beyond consumer-level tech, store excess power for continuous operation. Backup generators exist, but they're almost irrelevant because the real inspiration comes from the arc reactor, a concept built around compact, high-density energy generation. In reality, that translates into something like next-generation solid-state batteries, combined with experimental energy storage systems capable of delivering massive output without instability. The result? Energy independence. The house doesn't just consume power. It manages it, redistributes it, prioritizes it, ensuring that critical systems remain untouched even under extreme conditions. And yes, there are systems you don't see coming. Hidden compartments integrated into the architecture, mechanized platforms beneath the floors, structural sections that can open, shift, or reconfigure depending on operational needs. Because for Tony Stark, a house isn't just a place to live. It's a platform, a launch pad, a controlled environment where technology, architecture, and human intent merge into a single system. But there's one part of this mansion that takes everything you've seen so far and pushes it into something far more extreme. Because beneath the glass, beneath the steel, beneath the intelligence, there's a space that was never meant to be seen. Beneath the polished glass floors and seamless steel lines, there's a layer of this mansion that was never designed for comfort. It was designed for control. Because if the upper levels represent lifestyle, the lower levels represent capability. Hidden beneath the main structure is a subterranean complex that transforms the entire property from a residence into a private technological stronghold. Not a basement in the traditional sense, but fully engineered underground facility carved directly into the coastal rock. And building this is where things become brutally complicated. Excavating into Malibu's cliffs isn't just expensive, it's dangerous. You're dealing with fractured rock formations, groundwater intrusion, and constant pressure from the ocean itself. To make this space viable, the entire underground structure would need to be sealed using multi-layer waterproofing systems, membranes, drainage channels, and pressure-resistant concrete shells designed to hold back both moisture and structural stress. Think less home construction, more submarine engineering applied to land. The walls wouldn't just support weight. They'd resist the ocean. Inside, the environment shifts completely. This is where Stark's workshop exists, the birthplace of innovation, experimentation, and controlled chaos. A space where robotics, fabrication, and high-energy systems operate without limitation. At the center of it all, a robotic assembly platform inspired by Iron Man technology. In reality, this would translate into multi-axis robotic arms, similar to what you'd find in advanced automotive manufacturing facilities, capable of precision fabrication down to fractions of a millimeter. Ceiling-mounted tracks allow these machines to move freely across the workspace, reconfiguring themselves based on the task at hand. This isn't a static lab. It's a dynamic production environment. Materials are stored in automated systems, carbon fiber, titanium alloys, high-density polymers, each cataloged and retrieved by AI-controlled mechanisms. Need a component? The system identifies, delivers, and prepares it before you even reach for it. Because speed matters here, but power matters more. A facility like this demands energy output far beyond residential limits. We're talking about industrial-grade electrical systems, high-capacity transformers, redundant power routing, and isolated circuits designed to handle extreme loads without destabilizing the rest of the house. And then there's heat. Fabrication at this level generates enormous thermal output. Without proper management, the entire system becomes a liability. So the solution isn't just cooling, it's heat redistribution. Liquid cooling systems circulate through critical machinery. Heat exchangers transfer excess thermal energy away from core systems. Ventilation shafts, strategically concealed within the cliffside, release controlled airflow without exposing the internal structure. From the outside, nothing changes. From the inside, everything is moving. And security? At this level, traditional security systems are irrelevant. Biometric access isn't a feature. It's a baseline. Facial recognition, gait analysis, voice authentication, layered together into a multi-factor identity system that's nearly impossible to replicate. But Stark wouldn't stop there. The architecture itself becomes part of the defense. Segmented zones that can isolate sections of the facility instantly. Reinforced doors integrated flush into the walls. Systems capable of locking down the entire underground complex within seconds if a threat is detected. Because when you build something this advanced, you don't protect it like a house. You protect it like an asset. Now zoom out. Above ground, it's a masterpiece of modern luxury. Glass, steel, and open space floating over the Pacific. Below ground, it's a high-performance machine, hidden, controlled, and relentlessly precise. Together, they form something that blurs the line between architecture and engineering, between home and headquarters, between human living and technological evolution. And that's what makes the $300 million Malibu mansion so powerful. It isn't defined by how it looks. It's defined by what it can do. Because in the end, Tony Stark never needed a bigger house. He needed a smarter one, a stronger one, a house that could keep up with him.